APCACUS BC, Unit 9, Day 2, Office Hours. These are the 3 even problems. You should check your odds in the back of the book. Pause the video if you need to right now to check these 3 answers. Okay, assuming you've checked them, let's try these problems out. So this is really just more of the same kind of problems that we did for section 9.1. So on these ones, these first ones are looking for the radius of convergence. So we're going to write the problem down. These are all power series, so we got to start with the ratio test. And the ratio test says that the limit as n goes to infinity of the absolute value of the next term, x plus 5 to the n plus 1 term, divided by the previous term, the nth term, needs to be less than 1. So a lot of times we can do some simplification. This one's kind of interesting because if you take the limit, you're just going to get absolute value of x plus 5. The n's are gone, and this needs to be less than 1. So from here, you can see that is the radius of convergence. And the center is x equals -5. So you don't even need to finish finding an interval of convergence to find the radius of convergence. But if you kept going, and it's okay if there's something being added or subtracted to the x, that is the radius. If there's something multiplying the x, you'd have to get rid of that before you could determine the radius. So your interval of convergence is -6 and -4. We'd still have to test the endpoints, but because we're only looking for the radius, we don't have to do that. So that's 8, 9, so we're going to go directly to the ratio test. Limit as n goes to infinity, absolute value of -1 to the n plus 1, 4x plus 1 to the n plus 1 over -1 to the n, 4x plus 1 to the n. And we could simplify it. So rules of exponents, there's going to be -1, there's going to be this. So this is going to be -1 times 4x plus 1. And the n's are gone, so it's just going to be absolute value of 4x plus 1. That needs to be less than 1. So that's not your radius yet. So I mean, you could divide both sides by 4, and then the radius will be right in front of you. The radius is 1/4. Or you could go ahead and try and solve it first. So that's the interval of convergence. The distance from one end to the other is 1/2, so the radius has to be 1/4. So either way, it comes out the same. All right. 13. So we're going to do the ratio test. And absolute value, you need the absolute value, x to n plus 1 over n plus 1, square root of n plus 1 times the reciprocal. Rules of exponents gets you that far. But we could say, okay, well, n over n plus 1, square root of n over n plus 1 times x. Now that's going to be 1, that's going to be 1. So we're going to get absolute value of x that has to be less than 1. So there's the radius. You don't have to find the interval of convergence. The diameter is 2. The radius has to be 1. Except I forgot something. I forgot this 3. 3 to the n plus 1, 3 to the n. So there is a 3 in here. So if you wanted to, you can multiply both sides by 3, and then there's the radius of convergence. So I got it wrong. So the radius of convergence is 3. Just lost that 3. Okay. 16. These are getting a little messier. Okay, so ratio test. Limit as n goes to infinity of the absolute value of n plus 1, x to the n plus 1 over 4 to the n plus 1. And this is going to be n plus 1 squared. Should we go ahead and do, I don't know. Should we do it? Should we say n squared plus 2n plus 2? Because you get an extra 1 there. Times the reciprocal. We can clean this up quite a bit. There's an x. There's a 4. So we rewrite this. Now I would put we have this n plus 1 and n squared plus 1 over n squared plus 2n plus 2 times n times x over 4. Now, this is going to be n cubed. The biggest term, dominant term is going to be n cubed. That's going to go to 1. So we're going to get absolute value of x over 4 is less than 1. So you could multiply both sides by 4 and get the radius and the center very clearly. Center is 0. Or you could do this, however, it works either way. So the radius is 4, half the distance between the endpoints of the interval of convergence. Okay, 17. N factorial, x minus 4 to the n. Ratio test. N plus 1 factorial, x minus 4 to the n plus 1 over n factorial, x minus 4 to the n. That's going to reduce to that. This is n plus 1 times n factorial. So what we get is we get the limit as n goes to infinity of the absolute value of n plus 1 times x minus 4. Now, this is kind of an interesting scenario here, because we say, okay, well, if you take this to infinity, we're gonna get positive or negative infinity depending on what the value of x is, which is greater than 1, which diverges. But there's one special case where we can make this become less than 1, and that is when, because we're looking for x values that will make this be less than 0. When x equals 4, it goes to 0, right? So that means x equals 4 is the only place. This is the interval of convergence. It converges at one point. This is a special case. What would the radius be in that case? How far from the center does the interval of convergence extend? 0. Now, raised to 0 doesn't mean we don't have any answers, but this is a special case. It only converges for a single x value. Let's see. Number 18. So 18, ratio test, limit as n goes to infinity, absolute values of the square root of n plus 1, x to the n plus 1, over 3 to the n plus 1, times 3 over n, square root of n, x to the n. Okay. So rules of exponents and different things like that. We get an x, we get a 3. So we could say square root of n plus 1 over n times x over 3. Now, this isn't giving you infinity over infinity, but it's going to be 1. So we're going to get the absolute value of x over 3 has to be less than 1. You can multiply both sides by 3, and there's your radius. Or you could start solving it. But the radius is 3. Okay, we're not worrying about the endpoints right now. We would if we were looking for the interval of convergence. Okay, 29. These ones say determine the convergence divergence of the series, identify the test or tests you use. There may be more than one correct way to determine convergence or divergence. So I want you to try every possible way you know right now, other than comparison test or absolute convergence. So really just nth term test and ratio test. So first thing I'm going to try is nth term test. And that's the limit as n goes to infinity of n over n plus 1 gives you infinity over infinity, dominant terms, L'Hopital's rule. You're going to get 1, which doesn't equal 0, which means it diverges by the nth term test, which is the reason you always do it, because if it diverges by the nth term test, it's the easiest way to go. But let's go and try the ratio test too and see if it agrees, or if it might even be like inconclusive or something. Sometimes that happens. Now, this is all going to go to 1. It's going to be 1, which is inconclusive. It doesn't mean it diverges. Inconclusive. You don't know, because essentially that's the edge of the interval of convergence. It might work, it might not work. You have to do more tests on it. So let's see, 39. Now, 39, something interesting about it is it's a geometric series. We could rewrite it in a little more obvious form, but it's a geometric series, and that might be the fastest way to do it, because you're like, oh, there's an R value, and is it less? So, I mean, we could do that. We could say, all right, geometric series test, because it is a geometric series, and the absolute value of R has to be less than 1, and it is, so it converges by the geometric series test. So we could do it like that. Let's try nth term test, which is a test for divergence. It's usually inconclusive. Limit as n goes to infinity of negative 2 to the n over 3 to the n. So these are DOM terms. The bottoms grow faster than the top, which makes the whole thing go to 0, which is inconclusive. Ratio test. Limit as n goes to infinity of the absolute value of negative 2 to the n plus 1 over 3 to the n plus 1 times 3 to the n over negative 2 to the n. Rules of exponents. We get the absolute value of negative 2/3. The limit I still hadn't taken the limit, except that there's no limit to take. So it's less than 1. It converges by the ratio test, which makes sense, because that's what the whole absolute value, that's what the whole geometric series test is anyways. It's the R value being less than 1. Well, the R is the ratio. All right, 31. So I don't think this one's a geometric series. Now, your next test, what I'll probably do is ask you if it is a geometric series. I want you to then find the sum of it, that the sum s equals a over 1 minus r. But that's the only kind of series that we know how to do that for sure. 41, we try the nth term test. I want you to write out the name, show the work, very officially, limit as n goes to infinity, 3n over n cubed 2 to the n. Now, the dominant terms, well, we got both of these. And we get infinity over infinity. I think it's hard to decide. I mean, this guy dominates this guy, but it's getting multiplied by a cubic at the same time. So maybe we actually do need to do L'Hopital's rule this time. The derivative of the top of an exponential is itself times the natural log of the base. On the bottom, you have a product rule. You have n cubed times the derivative of that. It's going to be 2 to the n natural log of 2 plus 2 to the n times 3n squared. And so if we plug infinity in this, the dominant terms on the top, that's the top. On the bottom, it's going to be I don't know. I mean, maybe I think what we could say, I don't know if we're going to make progress here. I think 3 of the n is going to dominate this, even though it's a bigger base and this one's smaller and it has a sixth term. This really doesn't make a big difference in the long term. So I think it's going to go to infinity. It's not equal to 0. It diverges by the nth term test. Let's try the ratio test and see what happens. I wonder if we'll get into some of the same issues. So 3 to the n plus 1 over n plus 1 cubed 2 to the n plus 1 times n cubed 2 to the n over 3 to the n. Rules of exponents. So we're going to rewrite this as a limit as n goes to infinity of, we could put the n over the n plus 1 all inside a cubed times 3 over 2. That's going to go to 1, so we're going to get 3 halves, which is bigger than 1, which diverges. So, kind of interesting. That's it.